Hello everybody, welcome to another video lesson. Today we're going over arithmetic series now. So we're going to find the sum of n terms of arithmetic series. So let's get into our concepts. What is an arithmetic series? Well, you may have guessed it. It is just the sum of terms of an arithmetic sequence. Now we have two formulas for finding the sum of arithmetic series, and they look like this. Now you can write these down, or you should write these down, but I'm going to show you where these come from. S sub n is how we denote our series, right, our summations. So S sub n would be the sum of all the terms of an arithmetic sequence, right? And an arithmetic sequence has a common difference between each term. So if I write this out, going from left to right, I'd have our first term plus my second term would be the first term plus d. And then my third term would be the first term plus 2d, right? So I'm adding multiples of my common difference, right? Now I'm going from left to right from my lowest or my first term, my initial term to my final term. But now I'm going to rewrite this series going from my final term back to my initial term. And when I do that, I would have my final term and then going to my second to last term, that would be a sub n, and I would subtract my common difference. So see, when I go from my final term backwards, I am subtracting multiples of that common difference. And then I would end here with my initial term. Right? So I'm going to do something weird here, but you'll see why. I am going to actually add these equations together. That is how we get this, our formulas. So when I add these together on the left-hand side, I get 2 s sub n. And on the right-hand side, you'll start to see a pattern here. I've got a sub 1 plus a sub n here. And if I add my next two terms, well, I got a plus d and a minus d, so those cancel out. So I'm left with a sub 1 plus a sub n again. And then I've got a plus 2d and a minus 2d, so those cancel out again, and so on and so on. And my very last term, I would have an a sub n plus a sub 1 again. So the question is how many of these terms do we have? How many of these a sub 1 plus a sub n terms do we actually have? Well, we have n terms altogether, right? So wouldn't it make sense that we have a sub n plus a sub 1 terms, right? These combinations here, we're going to have n number of those because we had n number of terms. So we're going to rewrite this as n times a sub 1 plus a sub n. That's equal to, again, 2s sub n. And we just divide by 2 on each side, and we get our first formula right here. Now, what about this second formula? Where does this come from? Well, recall that a sub n is equal to a sub 1 plus n minus 1 times d, right? So I'm just going to plug that right in for this a sub n right here. And what do we get? Well, when I simplify this a little bit and I add my a sub 1's together, I get this second equation right here. So we can use both of these depending on what we are given to solve for our sums. So that's it for our examples. All right, first example, find the indicated sum of each arithmetic series. So we have our first series here. We need to first find out what our common difference is. So that common difference is going to be, I can figure that out by just subtracting the first term from the second term, and I'll find out that that's negative 18. And you can subtract the second term from the third term just to check that. But I'm going to confirm that it's negative 18. A sub 1 is this first term here, so that's 211. A sub n is my final term here, which is negative 455. And we need to know what n is, right? I don't know what n is. But that's okay. So we can use our formula here, because I have a sub n is equal to a sub 1 plus n minus 1 d, right? And I have values for a sub n, a sub 1, and d. So now I can use that to find my n value. So I just start simplifying this equation here, and I'll find that my n value is 38. So now we can use our sum formulas. Since I now know what n is, I'll plug in 38 for n, I'll plug in 211 for a sub 1, and I'll plug in negative 455 for a sub n. And when I simplify this, I get, or when I calculate that, I get that my sum is equal to negative 4,636. Okay, so you guys pause the video now and see if you can figure out this sum in summation notation. All right, I did this two ways, just calculating all the values and adding those up together, all the term values. Or you can do this the same way using the formulas. Now notice here, finding out what my n value is. My n value is always my initial term minus the first term, and then I need to add 1. Don't forget to add 1 there, okay? Because it's like if I have 1, 2, 3, 4, 5, okay? If I said this is 1, this is 5, okay, if n was 1 and our final term was 5, right, and you would say how many terms are in there? Hopefully you would see that if you just took 5 minus 1, that would only give you 4, right? But there are actually 5 terms here. This is my 5th. Try to draw this in there. Oh, okay, if I took 5 minus 1, that's going to say that there's 4 terms, but there's actually 5 terms here. So I need to add 1 in order to get the correct n value, right? So that's probably the most important part for this, this problem here, is making sure if you are to use this formula approach, then you need to add 1 when you're figuring out your n value. All right, second example, looking at applications, we have Lawrence playing a video game. He scores 50 points if he completes the first level. Each following level is worth 50 more points than the previous one. So when he completes the second level, he gets 100 points. The third level is worth 150 points, and so on. What is the total amount of points Lawrence will score after he completes the 9th level? So I know a sub 1 is 50, and I know that n is going to be 9, right? Because we're looking at the 9th level. So my d is going to be what? Well, we're adding 50 points each time, so that's going to be positive 50, right? And then a sub 9 we don't know, but that's okay. So I'm going to use my formula. S sub n is equal to n over 2 times the quantity 2a sub n plus n minus 1 quantity b. So we have values for everything. We can just start plugging this in. So I'm going to plug in 9 for n, 50 for a sub 1, 9 again for n, and then 50 for d. And then when I calculate this out, I'll find that Lawrence will score a total of 2,250 points after he completes level 9. All right, last example here, another application. Jason runs a lawn mowing service. He currently has 14 clients. He gains 2 new clients at the beginning of each year. He mows each client's lawn an average of 15 times. Starting now, if Jason continues to gain those 2 clients a year, and if he charges $30 per lawn, after how many years will he earn a total of $51,300? So we want to put all of this in terms of dollars because that is our final sum that we're looking for, this $51,300. So a sub 1 is actually going to be 15 clients times 15 lawns mowed for each client times $30 each time he mows their lawn. So my a sub 1 is actually $6,300. Now my d, that is how much he's increasing each year, right? So I have 2 new clients each year, and he's averaging, he's going to mow their lawns 15 times per year, and then he is, again, going to charge $30. So he's going to add $900 of revenue for these new clients that he gets every year. And then our final sum that we want is $51,300. What we don't know is our n value. N is how many years it'll be before he earns this total amount. So we can use this formula here and just plug in our values, and now we just need to solve for n. Solving for n is what we're going to do. So I'm going to distribute this 900 right there, and then start simplifying, okay? And we'll get this formula right here. So I've got 450n squared plus 5,850n minus this s sub n that we started off with, 51,300, is all equal to 0. So I just got everything from here on the left, or from this bottom left corner, and I put it everything on one side and set that equal to 0. So to solve this, we would just go ahead and use our quadratic formula, right? And we would get something like this. So I would get n is equal to negative 19 or 6. Now think of it, n is the number of years it'll take him to earn a total of $51,300. So that is a time value, right? How many years? So time, we're not looking back in time, we're looking forward in time. So time is not going to be negative in this case. So it's going to take Jason 6 years to make $51,300. All right, guys, that is it for this lesson. Good luck with your practice.